Thank you, Elena, for the nice, kind words. I'm very glad to be here with you. I like to bring some fun into testing, so I will bring some dragons into testing this time. Let me share my screen. So, yes, I make it to be that one out there. Okay. Great, so there it is. So yes, let's talk about what children can bring to testing, and story goes around my book, and obviously thanks very much for introduction. Some facts here in the printed format. My background, Knowit, 4,000 people, ICQB, global organization, TMMI, also a global organization. But let's get to the point. So the agenda for next 30 minutes or a bit more, I'll briefly explain how this book project came to be. Then we go into how children actually learn testing and why. We go more into fantasy as a way to teach testing. And then some experiences about how children have learned, what can we take from there, and then I'll take those points into how adults can learn, maybe in a different way, how adults can test, maybe in a slightly different way. All right, so let's go. Book project. I got my spark into writing really from James Whittaker. I was in his storytelling class, and he had a point that everybody has a story, and also a point that by telling a story, you get your ideas through in the most memorable way. So this is his storytelling manifest right there. So I really want to tell my story as well, and that is the story of testing tuned into a language that is feasible for anyone who is not yet in testing, and that is children, of course, but also adults who want their first touch into software testing. But why should we talk about testing for children? Well, we are already teaching coding to children in many countries, and I think we need to do it in more countries, and even in the countries that are educating children about coding, we are not really talking about testing. So there are lots of testing, coding classes, official classes in schools. There are coding clubs, there are books, all kinds of things about learn to code, but not really that much about testing. So testing is obviously a thing you learn a little bit when you code, but it's fairly random in a way that you can see it mentioned in the literature, for example, for kids. So I think we need to fix that and educate children about testing too. And so this is why I created the book project with the supporting material, which is available for free for anybody. So in one slide, the timeline, the idea about a software testing book to children came to me when I heard Finnish author Linda Liukas publishing a coding book for children of kindergarten age, which was called Hello Ruby. That was 2014. It was 2018 when I actually had time to write. That was in my year in Lapland with my family. We took a year off from work, sabbatical year. I wrote the book in Finnish. I translated it immediately into English in half a year. I wanted to have great illustration too, so I looked for illustrators. I found Adrian Zelf, really great dragons, as you can see. I set up a crowdfunding campaign to fund that illustration and also get started other ways. I looked for publishers in Finland and in UK. I chose Avain to publish my Finnish book and Austin McCall to publish my English book. Both are called Dragons Out, but obviously one in Finnish, one in English. Same content, same book. So they are now both published. I'm also very happy that there has been a donation campaign, which was very successful. Just in Finland, I was able to get ICT companies and associations to support this initiative, and we donated these Dragons Out software testing books to 60 schools, which was very, very nice. So I'm the author of the book, Kari Kakkonen, and my illustrator is Andri Insel. All rights are in a company that I set out for this purpose. I founded it, Dragons Out Oy, or LTD in English. And also, as Elena also mentioned, there's a free PowerPoint, which is also available in Turkish, for example. The number of languages is growing all the time. And so that's really something you can give to any teacher in the world, and hopefully get more and more languages covered. It's so totally free, so that's a good starting point for any school anywhere about testing. But so let's talk about fantasy. So why fantasy? Well, I think through telling a story about dragons and knights battling, I think we can convey an interesting way to explain concepts of IT, of coding, and testing. So the basic idea is that there are lots of different types of dragons. Well, in the real world, there are lots of different types of defects. So dragons are defects. And then if knights are battling dragons, then developers and testers are battling the defects. So actually, it's a nice comparison and offers lots of analogies to explain all different features and parts of our real world in ICT industry. So let me give you a few examples. This one is an annoying dragon. So this dragon is red. It has small wings. It doesn't fly. It does breathe fire. It likes to eat lambs. It is quite difficult to find, but once you find it, it's quite easy to get rid of it. Now, what kind of defect would have these same characteristics? Well, that is a memory leak dragon. So software is obviously somehow wrong, but you can't really find it. One reason you suspect there's something wrong, and finally you can find it. There's something wrong in code, and it leaks memory. But after finding, it's actually quite easy to fix. It could be just one change, one letter added in a line of code, and that's it. So similar characteristics on this defect as you had on the equivalent dragon. Let me give you a few more examples. Robbing dragons, so dragons that steal food and treasure. There are lots of these, green, gray, big, small, easy to find, hard to find, easy to get rid of, or hard to get rid of. So lots of different varieties of these dragons. Some fly, some don't, etc. So what kind of defects are there that are of different kinds? Well, functional defects. So most defects actually are functional defects. Something doesn't work. The calculation gives a wrong number. And some of these are severe, so they need to be fixed immediately when found. Some are cosmetic, doesn't really matter. But okay, if we find it, let's fix it also. So these are out there, and by talking about these severities, you get children to learn about priority as well. And then an example of mean dragon here. It's a black one. Flies, breathes lots of fire, it likes to steal food and treasure without being detected. So in secrecy. That's the key. So this is, maybe somebody guesses, this is a security defect. So black as black hat. So that's for adults to notice. Children won't notice this. But security defects, so very critical, of course. You don't want those criminals to hack into systems and break them or steal content or money or anything. Another example, underground dragon. So these dragons are not flying, but rather they are digging tunnels, and they are using the tunnels to access different cellars of castles and villages, and there find easy food. So this represents similarly defects that are under the software, so hardware defects. So sometimes you find after close inspection of something you think is a software defect, you notice, well, actually it was a hardware defect. So there's something wrong with the device, so you need to replace that device or the part of the device. I also have nice dragons, and why? Because there are nice dragons, there are nice defects, and because also the readers are after mostly children, and children actually like dragons. Like my son put it, I like dragons. Why do you kill the dragons all the time? Sounds like, of course, I don't kill them all the time. Actually, sometimes I just get rid of the dragons in these stories, but there are also nice dragons which actually help people. So these nice dragons, what they do is help people, and they represent defects that also help testers. So these defects would be, well, there are actually many kinds, but here I chose defect seeding or mutation testing defects. So that means that you put defects into the code on purpose, and then these seeded defects are there in the code, spread around the code. And then the idea is that once you have tested the whole software thoroughly, and once you have found all these seeded defects, at that moment, you probably also have found all the real defects. So it's a measure of test coverage. Helps you to decide what is enough testing. All right. So those are the examples of dragons. So of course, you also have human beings there in the story. So knights represent both programmers and testers. So just developers in the agile team, which is the big trend these days. And so some knights would be better at finding dragons, some knights better at killing dragons, in a similar fashion as some team members of an agile team would be better at coding the software, some better at testing it. So the knights are both, but it's not only the developers and programmers and testers who test, but also users. So villagers, children included, represent users of the software. So users can obviously test as well on purpose. They can be asked to help in pilot testing or acceptance testing or things like that. Or obviously, if a defect escapes into production, they will encounter defects in real life when they actually use the software. A specific type of a defect is hunter. So hunters actually can also remove dragons sometimes. If it's not too bad dragon, they can kill it or banish it. So in a similar fashion, in user organizations, you would have IT support or operations or technical support that can actually fix some of the problems that are in the system, some of the bugs. Not all, they would turn into the development team to get help if there's anything crucial. So hunters represent operations. And then obviously, if you have a DevOps world, you would have hunters working with knights. So I support all operations working with development teams or being in the same team, rather. There are also lords and ladies, so you need somebody to pay the bill. So lords and ladies maintain armies of dragons, and similarly, product owners and company management or leadership pay the bills of creating the software, and they give priority. They listen to the developers. There are also sages, which in the fantasy world help everybody with their expert knowledge. And in real world, expert knowledge that teams need is things like usability or security or performance. Any skill that is not maybe needed all the time, but every now and then, this is where experts come and help teams to do this specific types of testing. Okay, let's move to some results. So how have readers, so this would be teachers and children. There are also readers, or like adults who buy to themselves, and also adults who get the book for the children. But this part is about teachers. So I talked to a lot of teachers during this book project. I ran a few surveys, I think, to get some numbers, and it looks like, based on the teacher feedback, like the best age for this kind of approach to testing using this kind of book is 10 to 15-year-olds. Nice numbers in general. One question I asked was, on which class in your school do you teach testing in this way? And so these numbers and this graph are from the teachers who got those donations of books in Finland. So the biggest number here is coding classes. So we are saying that they are basically teaching testing in coding classes. So it also tells that they have coding classes. I was originally suspecting that math would be a good topic in schools where you could take testing and give some introduction to testing. And actually, when I ran the same survey in a teacher trade fair, math and coding got actually as many responses. So teachers actually think math is actually a good fit for teaching software testing. But remarkable is also that lots of different topics can be used to teach testing. So for example, mother tongue. So natural fit, you read a fantasy book, you learn reading your mother tongue also. Or it could be English class, you read a book in English, which is not your mother tongue, for example, and then you learn both testing and English skills. So nice fit. Another question I asked was about how do children think about this topic? What is interesting? Is it testing, or is it dragons, or what is it? And then the answers from the teachers who got the donations was that dragons and the story are the best thing, and ICT in general, exercises too. The same question for teachers in trade fairs. At trade fairs looks similar. So story and dragons are the best interest for children, which is something I suspected anyway, and meant as well. So by telling an interesting story, you get kids to appreciate something as a side effect, which is in this case software testing. So if you have a very good story, you can teach different things, but may not be as interesting without the story. So let's utilize dragons to help children get interested in testing. Oops, this one here. And where do I use a book? Is it in class or home or something? Teachers would say class, and teachers at trade fair also say at class. So the actual class is going to be teachers are together with the students. That's the best place to teach testing with the book. And I have 5 questions that I ask about the impact. So what do children think after learning testing? So to the question, what is testing? They say that it's many things. So it's a compilation of the answers. It's about finding bugs. It's about fighting dragons, of course. It's going through software with different angles. It's just using software, and it's fun. I think it's a good combination. Maybe something we adults also should think about. You know, let's not take testing so seriously. Let's have fun also. You know, let's just use it and see what we can find. Okay, how do you test? So we answer, try different values, just try different things, look for something interesting or strange, use a checklist, and generally just use and observe. So exploratory type of way of testing, really, which is maybe because I'm using exploratory testing exercise as one of the exercises there. Next one, why do we need testing, or why do you need testing? Well, because you don't have bugs, you want to check it works correctly. play a game faster. This is interesting because software means a game mostly to children. So when I ask them to choose any software, and let's just try to test that, they would usually choose a game in a mobile phone. So quite natural. This is what I think. In general, have good software. Next one, how do you learn testing? Well, not surprisingly, reading a book by testing, looking for strange things, coding, and trying out my own code. This is important. So children also learn to code, and it's valuable. They understand that when they code, they also need to test. Lecture, drawing dragons, which is one of the exercises in the book. So yeah, not surprising answers here. And here, final question was, what do you do with testing in future? And the answers fall into 3 categories. So yes, coding and testing, we need to do both. Some people would want to be testing professionals and would say, not for me, not that interesting. A natural set of answers. But I picked here 2 quotes which I like especially. So a 12-year-old boy said, I want to be a software tester when I grow up. Now this was fantastic to hear. I so like to hear this. This is what I looked for, of course. 11-year-old girl said, I want to be a coder and I need to test too. Another good thing that's fantastic to see happening. All right. Then here I have a checklist, exploratory testing checklist, which is inspired by children testing. So what do they actually do? They use, in the start, they can use an easy checklist, look for anything fun or strange, or just try to make something interesting happen. I can do this too. Look for things that slow down you. Think about what could be easier. Think about misunderstandings. Think about what's ugly. Think about how can I cheat in using the software. So this comes from, again, the gaming world. A possibility to cheat would be actually a bug in the software, but for a player of a game, it would be cheating, and actually they may not report a bug like that. They just like to cheat and be a bit faster with the game. Some people are like that, and check if things are work as expected. There are, of course, advanced checklists. So when children get more into it, they can actually go through all paths, try cancels, check instructions, and use software reading instructions. See if somebody else can do it, not just me. The same, get the same problem out, same defect appear. They can co coordinate. Let's do it to a system. They can both access at the same time and see if there's an effect, like slowing down. And try special characters, try different data. So really good checklist, actually. Simple, straightforward, gets you a long way before you stop finding defects. So why don't you use something simple sometimes? I think that's the key. So to put it together, you want to have different learning approaches. So draw, listen, read, use analogies of fantasy and ICT world, testing and test. Exploratory testing works for children. Next few bits are then of the research I did surrounding my book project. So first of all, obviously, we all know children learn in multiple ways. So here are just some ways I mentioned out there. Also, it's not just my findings, but also research says that using many learning strategies is a good thing. So it's better to learn by combining different learning approaches. Concerning storytelling, there's a piece of research that says that it actually works for everybody. You might first think it only works for people who are auditory, or listen to a story being read, or maybe reading. But also visual learners, also kinesthetic learners can get something out of storytelling. It actually works for everybody, and it's easy to remember stories. So if I talk about sages, with long beards and whatever, who are very, very good in something and help people, it's easy to remember. You need experts to support your teams. So storytelling makes things easier to remember. There's also some research saying that when do kids learn complex topics? Well, it starts at around 11 or 12. That's when you can understand more complicated things. You can start with basics like testing 2, actually just try things. But if you want to get complex ideas like coverage and what's enough testing, that's more complex, and a good time for that would be 11 or 12 years old. So putting together the 2 points, so my experiences with the book project and the research, I would say like there are 6 points how children learn. So by comparing to fantasy, that works. I've tried that a lot. By being very clear, very concise. So say it in simple terms if you can, then it's easier to understand. There's also a important point about emphasizing trying things out, exercising, also using many senses, so not just reading, but also practicing drawing dragons, testing, testing also here, just test things, you learn, you get to use your skills. Interesting was also the common sharing. This actually seemed to be the most popular element of my testing class. So when kids would do an exercise, like draw a dragon, they would also share the drawings in, I used Padlet, so they would share it in Padlet software, where they could each see what the others draw, what kind of results they got from the exercises. Also when they tested, what did they find. So sharing, doing things together is better than doing things on your own. That's good learning. Let's take that into how adults learn. So those 6 points, I've translated them to adult learning ideas. I did 1 slide for each, but here they are as a list first. So analogies, maybe not fantasy, but something else. Also the clear and concise point. Also the hands-on point, try things, not just theory. Use all the senses works also for adults, maybe in a different way, like mind maps. Common workspace also might work in a different way in practice, for example, Mural. And then testing, well, test, it works also for adults. So let's have a bit closer look at these things. So what kind of parallels would work, analogies would work for adults? Well, fantasy also works for adults, but maybe more common would be something that everybody is familiar with. So it depends on your audience, of course. So when you teach something, you teach testing, and you know your audience, you can take an example that everybody knows. So it could be a sport like rugby here. It could be pets, anything that everybody knows. And then you can convey your analogy about testing. Clear and concise communication. So when you teach testing, it's the same thing for adults. If you can express your testing ideas in a simple manner, they are more easily understood. And so this is what I actually do nowadays more and more, trying to simplify the core content of what I'm saying about testing. It also, of course, carries to testing itself. So when you test, you want to very clearly communicate why you test, how much you test, what did you find. That is essential to make testing useful. Concerning hands-on part, so trying things, not just learning things by theory. I think it's very important to get to exercise anything you learn. To emphasize this, for example, ICQB is including hands-on learning objectives these times to also by there. In general, when I have a testing class, for example, I want to have lots of exercises and people working together. Anything can be made to be an exercise if you just think about it a little bit. Using all the senses in adult learning means that, okay, it's not only instructor explaining things or showing slides, it's also about talking, getting group work. As a group, let's or as a team, let's think what we can learn. What did we learn about this? What does it mean for us? How can we rephrase it in our own words? Because that creates brain work and that creates more learning. It's also about using your hands. So one of the senses would be your touch, your sense of movement and feeling something. And so here I would recommend drawing mind maps or any other form of notes that you like. My personal favorite has always been mind map. I've been keeping mind map notes for 25 years. Very useful, very quick. These days, with lots of pandemic putting us behind the screen, I've actually changed my mind. This is not anymore the best way to keep notes. I'll share it in the next slide. But mind maps are great. And even if you throw away your notes afterwards, it's still better learning. You learn better because you use multiple senses. It's as simple as that. So keep notes. Don't just listen. Keep notes. Even now, keep notes. Great. So the next thing, that was the shared learning. So common workspace. So in adult learning, that's often called group memory. So what that means is that we need to have a place where everybody can access, everybody has the rights to access it, everybody can write on it, create content, everybody can see what was agreed, what did we create together. So let's not have the secretary somewhere in our meeting keeping notes about what was tested or something like that. Let's have a transparent place where everybody can see what's happening. And in practice, that's often a whiteboard tool where you can add content immediately and arrive to a conclusion. Everybody contributed so quickly. My personal favorite is Mural, but there are lots of other tools, Miro, also concept board. Microsoft has their tool, Zoom nowadays have their own tool also, etc., etc. But have a common tool, a common shared workspace. And the last one of the 6 principles of learnings was start testing immediately. Now, how can you apply your new testing skills that you learned today into something? Maybe your project doesn't have something to test at the moment. So where do you find testing content? My solution there has been for many years actually cooperation with startup companies. So there are lots of small companies that actually struggle in getting enough resources to test. So why don't we do some cooperation? We learn to test as testing professionals, and we get to practice in their test environment with software that actually has bugs, and it's interesting to find bugs. It's more interesting to test when you find bugs. And what they get in return is reports about these defects. So if we find a defect in our practice of testing, we let them know and they can fix it. So that's really a nice win-win. So that's something I would recommend you to try. Well, and that brings me to the last slide, which is thank you. You can follow me in multiple places, as you can notice there, my website, social media, and obviously you can get the book, and on regularjob.com you can get the free PowerPoint as well in many languages. Are there any questions?
First of all, thanks a lot for this remarkable presentation, Kari. That was really wonderful.
Seeing the presentation, I felt I want to be a child again and be taught about testing from the very beginning.
Indeed. So does anybody want to ask anything?
Yes, please, if you have questions, you can raise your hand or write it down on Q&A section.
So we're having some minutes here and we have Kari with us. So take the chance to feel like child for some minutes.
You can also drop an email, of course, which you can see there if you get the question later on. I'm happy to answer.
Okay, so we have one question.
All right.
You can see it on the Q&A section, actually. It's from Melinda Petzold. She's asking, will the story continue? Dragon's Out Part 2.
It can. I left the story at the point where there could be a second book. The story where the children are having their adventures, it has a natural continuation there. And also I could talk about more about different ways to test. The structure of this book was the different types of defects and how do you test to find them. There are natural ways to continue. But at the moment, the focus is in getting translations of this book to different languages. So currently there are French, Polish, German, and Hungarian project quite well ahead. So I'm putting efforts there at the moment.
Okay, perfect. And we have one question also for Umut Karamakaptan. I'm going to allow for him to speak. Sure. With the microphone because he's raising hands. Yes, it's your turn.
Go ahead.
Hi. First of all, it seemed like a very interesting book, and thanks for the work. I already start rolling the pages. But when I look at the content, the book is more likely for maybe a secondary school, or at least after the 4th or 5th grade age from the reading level. When I look at this, would you like to also kind of work on even the earlier age group? Because what Barış actually made very obvious for us is to be a good tester, it is not only for finding the work, or it is not the algorithmic way of just covering the software, finding tests, but it is also the empathy and understanding of problem resolution techniques, and also understanding the design considerations and so. And when you look at that perspective, it can be also cultivated for many other things, not only for the software testing, but with the same idea in the perspective. Would you like to also focus the upcoming part of the story a little bit for the younger ages?
That could be, but I think really next book may go into more difficult direction. But this book also can be used to different ages. So the teachers have used it to grades 4, 5, 6, 7, 8, and 9. So actually, and I think most teachers would, the average, most teachers were on 7th grade who were using it. So it actually works to quite a big, large range of kids. Also, adults have read it to even 4-year-olds because the story is engaging. Children may not get all the testing concepts that time, but they can get a spark of thinking that testing is interesting. So even today it can be used to younger kids as well. But concerning the bigger thing around testing, I think it's about critical thinking skills, which is a skill that anybody in the world needs. So if you learn testing skills, you also learn critical thinking skills, which can help you anywhere in the world. Anywhere, whatever you do as your daily life, and I think that could be an emphasis of further work. Thanks for a good question. All right.
Thanks a lot for the answer.
Yeah.
Thanks a lot for the answer, and thank you so much for this remarkable presentation, Kari. We are so happy to have you here.
Thank you.